Hello, everyone. Thanks for being here. Today, we'll be presenting the website we've designed to support the Closing the Gap initiative, a national effort to improve outcomes for Aboriginal and Torres Strait Islander people. Our aim was to create a website that presents important data in a way that's clear, respectful, and easy to understand. We wanted to make sure that the content would be useful for a range of users, including students, community members, and professionals. In this presentation, we'll explain our design process, some of the choices we made, and how we focused on accessibility and simplicity.
Okay, so the first section will answer the question, how does our website meet the requirements of grade level? Now, the first thing users see when they open the website is this eye-catching hero section with the highlighted word close to that on it. Move to the next slide, we'll show that below the hero section is the carousel card that displays 17 socioeconomic outcomes and targets. So we also put a Learn More button inside for users to navigate to the government Closing the Gap page for more information. Now move on to the next slide. The next slide shows that our main outcomes for this way. Okay, so the website only focused on two outcomes to provide statistical data to tables. So we add a small section below the carousel card to specify our main target outcomes, which are outcome 1 and 5. So when user hover to the card, the text and button will pop up. And move on to the next slide. This is the population table. So the population statistics for each Australian state and territory from 2016 and 2021 are calculated and retrieved from the database. So user can filter by year to view the population figures. Now move on to the mission statement of our website. We added one mission on the landing page and one on the About Us page, although the contents are a little different, but they both explain the purpose of our website. Now, to enhance user friendliness, we include a dedicated FAQ page. I'll move on to the next slide. We include a dedicated FAQ page that answers the question about challenge and provide guidelines for reading and interpreting data, like this information about each data set, for example. Now, onto the About Us page. This is where we include all the team members' information and the persona information. Those information are stored and retrieved from the database. And this next slide are our free persona. We will dive into that in the later section. Now, on to level 2. We aim to provide a simple, readable data table showing the user the selected dataset statistic. So we integrate a filter bar on the left that allows users to sort by all the LGA, state, row value, percentage value in ascending descending order. The selector in the filter section incorporates a drop-down menu. So the table on the right displays the LGA and state information, the ranking of each LGA or state, the row total value, and proportional values. Now the next slide, I'll show you that we add a little function when we view by state, there are only 4 columns, but when we view by LGA, it's going to display 6 columns, and the headline also changed to LGA. And the next slide is the edit about the subtask 2B of the education page. It has the same features and layout, but the difference is that the multiple selection in the category section. We added a toggle function to it, so the checkbox area only display when needed. Now to the level 3. The level 3, we on this comparison page, we added 2 smaller pages inside it, one to show the change in the gap of indigenous and non-indigenous across the year, and the other one is to find LGA with similar attributes. So user can choose the dataset they want to examine further in those sections. And how on to the next page is more specific about the gap change page. So we provide the user a way to, we provide a way for user to see the most significant changes by highlighting it in different color. So they are highlighted in green, which represent the LGA with the best improvement for narrowing the gap in 2021, and in red to represent the LGA with the worst decline in reducing the gap in 2021. Now, the next slide, please. The table, when user mistakenly input the wrong age range, like the minimum one was larger than the maximum one, it will pop up a warning message. And a little note here that the dataset 2 about health condition, it does not have the 2016 statistics, so we can only calculate the gap in 2021. Okay, so we move on to the subtask 3B about finding similar LGA. According to requirement, we added a input section for user to select the number of displayed similar LGA on the table. And we also let them to choose a LGA, so we don't have a default table record. So we added a little message to ensure that they remember to choose one. And finally, the sorting order. We provide the user way to see how the other LGAs are similar to the selected one. So the descending order, which is the default sorting order of the table, will show the user all the LGAs that are most similar to the selected one. And if the user wants to see the list similar to the selected one, they're going to want to change the sort order to ascending. So that's all for the requirement satisfaction section. She will introduce you the UX UI design of this.
Right, so moving on to the UX UI part of our presentation, I'll be covering 4 key areas that guided our design process: the personas we designed it for, the scenarios that shape real-world usage, how our design aligns with Nielsen's 10 usability heuristics, and the design paths we follow to support clarity, consistency, and ease of use. So let's begin with the personas. To ensure that the web application is truly user-centered, we designed it around 3 distinct personas, each representing a key user group. First, we have Mary Thompson. She's a 15-year-old Year 9 student doing a school project. She's looking for simple visual information about education and health outcomes across different states and LGAs. Her main goal is to find standout areas she can highlight in her presentation. What frustrates Mary is when websites are too text-heavy or assume prior knowledge. So for her, we've made the website that includes beginner-friendly visuals and easy-to-read charts. Next is Karen Karaoke. She's a 41-year-old engagement officer working in an Aboriginal community. She needs a clear, easy-to-navigate platform with filters, definitions of words, and color-coded visuals that show where improvements or concerns lie. Her goal is to compare stats between Indigenous and non-Indigenous populations to support community discussions. Karen gets frustrated by overly technical charts and harsh visual designs. So we prioritize gentle color schemes, clear summaries, and approachable data displays to keep the experience both informative and comfortable. Lastly, we have Noah Bennett. Noah is a 38-year-old politician focused on Indigenous education. He needs reliable, detailed data with strong comparison tools, especially to analyze changes between 2016 and 2021 across different LGAs. His goal is to understand which policies have worked and where improvements are still needed. His pain point includes slow website and poor visual design that slows down his decision-making. To meet his needs, we focused on site speed, clear layout, and in-depth, but well-structured data views. Each of these personas help us build a website that is not only functional, but also engaging, accessible, and tailored to real-world user needs. So let's move on to the context scenarios. Our design also supports these, but I won't be diving into them as we'll be stepping into their shoes later on in the demonstration to show exactly how the site supports the different use cases. For now, I'll move on to the Nielsen's usability heuristics. So we ensure that our application follows each and every one of Nielsen's 10 usability heuristics. Keep in mind, there are certain elements of the website that satisfy multiple heuristics all at once. So let's begin with the first one, visibility of system status. Our website excels at keeping users informed about what's happening through clear visual feedback. Some key features include active navigation highlighting that shows users exactly where they are. We have filter selections that are visually indicated when applied. We also have tooltips that appear in hover, providing immediate feedback. Moving on to the second heuristic, match between the system and the real world. We've ensured that the system speaks the user's language, not technical jargon. So key features, we have tooltips that explain specialized terms in plain language. We also have a frequently asked questions page that has detailed explanations on complex or unfamiliar terminology like LGA. We also have the Learn More button across multiple elements that uses familiar language and gives the opportunity to users to gain access to more information should they want to. Moving on to the third heuristic, user control and freedom. Our design provides clear emergency exits and control over the experience. Some key features include the clear filter button that allows users to start over, and the back to top button, which provides navigation control. Moving on to the fourth heuristic, consistency and standards. We've maintained consistency throughout the interface and followed web conventions. We have consistent visual elements across all pages, as you can see. We have standard interaction patterns for filters and tables. They function just as expected. We also have tooltips that follow expected behavior patterns. Right, so let's move on to the fifth heuristic, error prevention. Our design helps users avoid mistakes before they happen. Some key features that demonstrate this are structured drop-down menus, prevent invalid selections. We have tooltips that explain data categories before users interact with them. We even have clear labeling, which prevents misinterpretation. Right, so moving on to the sixth heuristic, recognition rather than recall. Our interface minimizes the user's memory load by making options visible. Key features include the all filter categories are visible above the drop-down menus. This means that the user won't have to remember the category of the drop-down box to change their selection later on. Additionally, applied selections are also visually indicated, so users don't have to memorize their selections. The seventh heuristic, flexibility and efficiency of use. As you can see, our design allows users to add multiple paths to reach the same dataset, whether that's through the main menu, quick access links, or contextual buttons placed throughout the site. Now, the back to top button provides efficiency, especially on pages with longer content, so users don't have to scroll manually all the way up every single time. And for users who might need a little extra help again, tooltips are available throughout the site. Let's move on to the eighth heuristic, aesthetic and minimalist design. We focused heavily on this. Now, as you might already know, a clean layout with appropriate use of white space helps guide the user's attention and make navigation feel effortless and uncluttered. As such, we designed it to follow that. Data is presented in a clear and concise way, avoiding any visual overload. Charts and tables are designed to highlight key insights without unnecessary noise. We've also created a lot of custom-drawn assets that are deliberately simple and symbolic. These visuals support the content rather than distract from it. Finally, our color palette was carefully selected to maintain visual harmony. It helps reinforce the tone of the content while avoiding harsh contrasts or distractions, ensuring a smooth and engaging experience for all users. So let's move on to the ninth heuristic. Help users recognize, diagnose, and recover from errors. The clear filter button helps recovery from unwanted filter combinations. There's clear visual feedback if an error happens, whether this be a missing database, incorrect input, or if our design lacks anything, it helps users understand and recover from mistakes. Lastly, our design provides contextual help exactly where and when it's needed. The 10th heuristic, help and documentation. So we have a frequently asked question page which addresses common questions. We have tooltips which provide just-in-time documentation directly in the interface. All right, so now that we've covered all the 10 Nielsen's heuristics, let's move on to the standard design patterns that improve usability. Let's begin with navigation design patterns. So we have the first one, a sticky menu. What is it? So no matter how much you scroll, the navigation bar sticks to the top of the page. This helps with navigation. What about home link? So it's quite simple, really. As you can see in the corner right there, the logo helps you teleport right back to the home page, acting as a sort of an escape hatch. So let's move on to the carousel. So a carousel is our innovative solution to prevent clutter on the landing page. Because there are 17 socioeconomic patterns, we can't simply present all of them on the website directly. So let's move on to the fourth one, cards. So we've further emphasized the two main outcomes of our website, outcome 1 and outcome 5, through the usage of cards. What about module tabs? As you can see in our comparison pages, the module tabs design pattern organizes related content into clearly labeled tabs, allowing users to easily navigate between sections without leaving the page. Lastly, we have progressive disclosure. It's the design pattern that reveals additional information only when needed. As you can see, the see more or see less button. All right, so let's move on to the last thing, the data design patterns. So firstly, we have the table filters, which allow users to quickly narrow down visible data. Next, we have alternating row colors, also known as zebra striping, which help with readability of the table. Lastly, we have the detailed FAQ, which ensures ongoing guidance for users at all levels. Now that we've covered how usability shaped our front-end design, I'll hand it over to Bao, who will walk you through that database side of the project and explain how our data is structured and managed behind the scenes.
So let's talk about our closing gap backend. We built a strict system to track health and education outcomes from 2016 to 2021, focusing on closing the gap goals. It owns about having marries. So let's move on to the error modeling. Our error model is a clear map for everyone. It got 9 entities like LGAs for area data, age demographic for age stat, and LGA mappings to connect 2016 and 2021. LGA's link dataset for health and education, while LGA mapping ties 2 years together. It nails every subject, like social economic outcomes and for Mary's landing page, Rosanna's for Karen's mission statement, and LGA mappings for Noah's gap analysis. It is a UML compliant with proper keys and relationship. making data easy to grab and super clear for our users. So let's move on to the database creation. So we built a solid SQL database to bring this map to life. It got on 9 tables like LGAs with LGA code and year, LGA mappings for yearlings, and the 5 VTTP lost everything like the CSVs for dataset, plus static data like 17 outcomes and 3 personas for Mary and Karen. Our reprocessing is top-notch, like split CSV line handles messy CSVs and generate LGA mappings. It maps LGA like the Army regional perfectly. This gives Mary's visual clean, Karen's clear, and Noah data trusted with no suspicious. And also in terms of our queries, can I have the next slide, please? Our queries are perfect. The JDBC connection Java supports every subtext, like get state populations for Mary's landing page, get personas for Karen's mission, and get gap data LGA for Noah's for gap analysis in 2016 to 2021. They are clean using the CTE for speed and handle on the input, like the fields of Karen trends are sorting from Mary's visual. Indexing make them zippy, so Noah's gap analysis applies. Every query is error-free, like this is perfect. There's no error on the query and giving spot on the result of on our users, no matter what they need. So in terms of the relational schema, so can I have the next slide, please? So in terms of the relational schema, we got 9 tables with the LGAs with LGA code, item graphic for start, and LGA mappings for the yearlings. The contract keep it tight, like a check on LGA start or the frozen key tying LGA graphic to LGA. It matches our error model perfectly with no errors and borrowing the Mary's visual, the Karen trend, and no for gap analysis. It is on setup data, clean, reliable, so everyone will get what they need and fast. So can I have the next slide, please? Okay, so in terms of the 3NF error models, it's super clean. We have created 9 tables like LGA with LGA code and LGA mapping for 2016 to 2021 links. LGA connect datasets one to many, while static table like personas standalone. It is 3NF, single value attributes, full K dependencies, and no non-K links like LGA graphic could depending only on ID from LGA mapping, got redundancy, and boosting the Noah's query speed. This setup makes Mary's chart perfectly and count trend bulbs. Also make the Noah's analysis smoother. So can I have the next slides, please? Yes, it is the GNF error model I have created in the memory for the efficiency and more cleaner. So I think that's all for my part. So let's move on to the backend implementation.
So my name is Minh, and I will be handling the demonstration of our website. So first, let's step our shoes into Mary Thompson's shoes. So let's say Mary wants to gather health and education stats for her school project. So she opens the home page, and she can see that the health tab is right here. So she clicks on it. She's greeted with various filters that she can tune to her liking. So she decides to view by LGA in the health dataset, and she wants to see the statistics of people who are suffering from strokes, of both indigenous and non-indigenous, both genders, percentage, and in descending order. So the website quickly changes to display her wanted information. So she can quickly scroll down to screenshot whatever information she thinks is relevant. So next, she switches to the education tab. The same filters greet her. So now she can tune by, she selects year 12 equivalent to see the graduation rates. And thing, info loads out. She can review by LGA if she wants more specific details. All right, so next is Karen. So Karen is in a planning session and wants to find LGA similar to Adelaide for the outcome 1, health. So she clicks on the comparison page, go to find similar LGAs, select outcome 1. Then she sort data by age. Age range can be 1 and 12, for example. So she selects her own LGA, which is Adelaide for the comparison in 2021. And there, the table loads and her own LGA is highlighted in a soft green. If she wants to see more, she can customize it. Yeah. The table can now load everything she wants, so she can take relevant screenshots to present in her meeting. So lastly, we have Noah Bennett. So Noah wants to see how education outcomes have changed over time. So he can see which state has the best difference, which has the worst improvement. So he can then categorize the information and see which state has good policies and whatnot. So firstly, he selects dataset 3 and filters by year to 1 to 12. So he sees LGAs with the most improvement in pastel green, and the LGA at the bottom with the worst improvement will be in a red highlighted color. Then he switches to dataset 1 to explore indigenous population trends and screenshots what he needs for his policy meeting. So same thing, same filters. Sorts by different percent in 21 to 21, for example, ascending, age range 0 to 12. So now it will display the worst performing state, and he can scroll to the very bottom to see the best performing states at here. So that concludes my demonstration. I will now hand it back to Tri for the outro.
Right, so to wrap up our presentation, our goal throughout this project was to design a website that presents data in a way that's clear, respectful, and useful for a diverse range of users. From defining our user needs and user scenarios to applying usability principles and thoughtful design choices, we aim to create a platform that's both meaningful and accessible. Thank you for watching our presentation. We really appreciate your time and interest, and we look forward to hearing your feedback. Thank you.